Hey boys, welcome to today's lesson. Today we're looking at the volume of prisms and cylinders. I think you've done a lot of this before, so the volume shouldn't be too hard. The only issue is I see a lot of boys, when they say a volume of a prism, we tend to think about a rectangular prism and we say, oh, just multiply the three sides together. Be very, very careful with that. We only do that if it's a cube or it's a rectangular based prism. Now, the reason for that, if we actually look at the formula for the volume, the formula should say the area times the depth. Now, what am I talking about when I talk about the area with a prism? I'm talking about the area of the cross section or the cross-sectional area. Now, if we talk about, let's say example 2, what's the area of the cross section? Well, the cross section is the triangle there, and then we simply times it by the depth. Not a bad thing, right? So as long as you know where the cross section is, you know how to find the area, times it by the depth, and you're good to go. So try to get out of the habit of saying side times side times side, okay? Because it only ever works for the cuboids, the cube or the rectangular based prism. Now, as I mentioned last lesson, we have to separate prisms and cylinders because a cylinder is not a prism because it doesn't have a vertice, all right? So a cylinder is still exactly the same thing. It's still area times depth. There's no real change there, okay? It's just because it's not a prism, we kind of separate it, and the area of a circle, as we know, is at pi r squared, so pi r squared, and then the depth we kind of call the height of the cylinder. And so we tend to have this kind of set formula of pi r squared h for the cylinder, whereas the volume of a prism, because there's lots of different types of prisms, we just say area times depth. So let's have a look at some of these questions. Pause it, crack through. You probably should be fine with this stuff. The first one, of course, we've got a cylinder. So it's simply just pi times the radius squared. So pi times 4 squared times the height. Volume equals 4 squared is 16 times 10. It's 160 pi centimeters, and it's cubed. Okay, again, I'm going to leave an exact value. I like doing that, but if you want to do significant figures or decimal places, then go for it. Example 2, we have a prism, of course, because we have a constant cross section. So we can do half times the base times the height, and we times that by the depth. So again, that's the area times the depth. Volume equals half of 6 is 3, 3 fours are 12, 12 twos are 24, 24 centimeters, and again, it's cubed. Not that hard. 3, a little bit more challenging. We have like a cylinder, but it's kind of got like a hole through it, so it's kind of like a tube or a tunnel. So a couple of ways that we could do this. The first way is we could find the area of this cross section, okay, this circle. We could do that by saying the area equals pi times radius of the big circle, 4 squared, minus pi times the radius of the small circle. It's a 4, by the way, if you can't see that there. So it's 2 squared. That's what the area of the cross section is. And then, of course, to find the volume, we can then times it by the 10. Okay, so 4 squared is 16 pi. So we get 16 pi minus 4 pi, and we're going to times that whole thing by 10. So that makes it 12 pi times 10. That makes it 120 pi centimeters cubed. Okay, again, I'm going to keep it in exact form. Now that's one method you could have used. What you also could have said, let's find the volume of the big cylinder, okay, which would be pi times 4 squared times 10. And I'm going to then subtract the volume of the smaller cylinder, which is pi times 2 squared times 10. Okay, and again, what you're going to get is 4 squared is 160 pi minus 40 pi, which again equals 120 pi units cubed. So it's not that hard. You do need to know your area formulas. If you don't know your area formulas, then volume is almost gone. So you need to learn your volume, your area formulas off by heart, so you can then find your volume. Just remember, if you cut an object in half, so let's say, for example, we cut this cylinder in half. Now, in the past, when we did surface area, when you cut it in half, you create another surface. When you're doing volume, there'll be no change. Remember, volume is what's inside. And so you don't really change much apart from just halving it. Excuse me. Now, the only other thing, of course, is you might have some capacity questions on top of volume, remembering that 1 centimeter cubed, okay, equals 1 milliliter. if I want to look at 1 meter cubed, I wonder if you can remember what the capacity is of this. It's actually 1,000 liters. Think about a meter cube. It's massive. It fits a huge amount in. Okay, it's 1,000 liters, whereas a centimeter cube is like this. So it only fits 1,000,000. So once you know what your volume is, you can then find the capacity, 1,000 liters. You can find your capacity as needed. The only other thing I guess would be your conversions, which we spoke about before, the kilometers cubed to meters cubed to centimeters cubed to millimeters cubed. And we did this with the area and we spoke about it with the volume. Okay, just means instead of timesing by 1,000, we're timesing by 1,000 cubed, times by 100 cubed, timesing by 10 cubed, and vice versa. Okay, and of course you'd expect your answers to be quite a lot. You know, again, we can always come back to a 1 meter cube. 1 by 1 by 1, of course, is going to be 1 meter cubed. But if we turn it into centimeters, we got 100 by 100 by 100, which you can see here is 100 cubed, and it kind of works out. Guys, I hope that makes sense. As I said, it should be okay, but it's just a lot of working out. So please try and take care with your setting out, because the better you set it out, the more accurate you'll be. Have a wonderful day.